Now, number 25, we've got a geometric sequence, square root of 2, then it goes to 2, then it goes back to irrationals, 2 square root of 2, and so on. We want to find two things here. We want to find the 10th term, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the sum of those 10 terms. So first up, let's use our general formula for our a sub 10. So here's what we'll have. The nth term is given by a1 times r to the n minus 1. And what do we have here? N is equal to 10. R, well, a1 we know, square root of 2, and r, we're going to have to get r. So to get r, take maybe the right term, divide it by the left term here. So what do we get? We'll take 2 square root of 2 and divide it by the term immediately to the left, 2, those cancel, so we will get square root of 2. So r is equal to the square root of 2. Let's see if that makes sense. So what we're going to say is we get from one term to the next by multiplying by the square root of 2. So what if you're up here? Square root of 2 multiplied by square root of 2, yeah, you get square root of 4, which is 2. So then you have 2 times the square root of 2. Yeah, it seems to work. All right, so we've got r. So now a sub 10 is going to be a1 square root of 2 times r, which is square root of 2, to the 10 minus 1. So a sub 10 is going to be the square root of 2 times the square root of 2 to the 9th. And now I've got a square root of 2 times square root of 2 to the 9th. So I got 1 here, 9 here. So how about a sub 10 we could write as square root of 2 to the 10th. Now you could try that on Wolfram Alpha or even your calculator, but here's one way to think of it. I know the square root of 2, the square root of 2 squared, that's 2. So how many of these square roots of 2's do I have in 10? Well, there's 5 of them, right? Here's what it looks like. I have square root of 2 squared, square root of 2 squared, square root of 2 squared, that's 6 of them. Square root of 2 squared, that's 8 of them. Square root of 2 squared, that's 10 of them. And each one of these is a 2, right? Square root of 2 squared is a 2. So I'm taking 2 times 2 times 2 times 2 times 2, which is just 32, right? So I'm going to claim a sub 10 is equal to 32. So the 10th term out here, I'm claiming is 32. Now let's add up the first 10 terms. So this is going to be s sub 10. Now we have a formula for this. In fact, I'm going to write that here. I'm going to write s sub n. Here's our formula. Our formula goes like this. It's a1 times r to the n minus 1 over r minus 1. Now in our case, n is going to be 10. A sub 1 we know, first term in the sequence is square root of 2. R is square root of 2. Put all these numbers in here. So we're going to get s sub 10 is, okay, first term, square root of 2, times, all right, what do we have? R, which is square root of 2 to the n, which is 10, minus 1, all over square root of 2 minus 1. Let's just trace that and make sure we're okay. A1 is square root of 2, right? That is the first term in the sequence. And then parentheses, I got that. What is r? Well, r is the square root of 2, but I want that to the 10th power, right? A sub 10, or n is 10. So I get square root of 2 to the 10, and then a minus 1, right? Minus 1, all over square root of 2 minus 1. So we're going to get s sub 10 is equal to square root of 2 times, now this one we just did, didn't we? Square root of 2 to the 10th. We just did that. That's a sub 10. There it is, right? Square root of 2 to the 10. That's 32. So we just happen to have that one. 32 minus 1 over square root of 2 minus 1. Now, we're close. I've got an expression here that has a radical in it, and I've got a radical in the denominator. What we're going to do is we're going to rationalize the denominator. So what I'm going to do here is this. This may look familiar now. We're going to get square root of 2, 32, well, 32 minus 1. We can do that one, right? So what do we get here? 31 over square root of 2 minus 1 times, all right, I'm going to rationalize the denominator, so I multiply by the conjugate. Square root of 2 plus 1 over square root of 2 plus 1. So I'm going to start just by indicating the multiplication. And instead of square root of 2 times 31, I'm going to write the 31 out in front. So I'm going to write it like this. 31 square roots of 2 times that top, square root of 2 plus 1, all over. Now, conjugates. Do you remember the rule for conjugates? You square the first, put a minus sign, square the second. So you square the first, put a minus sign, square the second. Just a quick reminder here. If I had something like this, say I had x plus 4, x minus 4, they're conjugates. I square the first, x squared, and then you get what? Negative 4x plus 4x. The middle term goes out, so minus, and then you square the last, 16. So that's all I'm going to do here. I'm going to square the first, put a minus sign, square the second. So square the first, square root of 2 squared is 2, minus square the second, I get a 1. Well, that's nice, all right, so here's where we are now. 31 square roots of 2 times square root of 2 plus 1. Now, I guess I could leave it like this, or I could just multiply it by through. I'll just multiply it through. So I'm going to get I'm going to get S10 to be, now, this will be what? 31 times square root of 2 times square root of 2. So it's going to be 31 times square root of 2 times square root of 2 is 2, plus, and then I've got this, 31 square roots of 2 times 1, which is 31 square roots of 2. I can multiply there, so I'm going to say this is going to be my answer here. If I add up those first 10 terms, I'm going to get 31 times 2, 62, plus 31 square roots of 2.